Hi everyone, this is Soumyadeep Paul, a mentor at CodeCardos and a software developer at Amazon. And I welcome all of you to day 13 of our system design series. Now in this video, we will be learning what is called as types of consistency. Okay, types of consistency. Now in the previous video, we learned what is consistency, what are consistent systems, what are inconsistent systems. Okay, and we also learned that in general, distributed systems are inconsistent in nature. So us as good developers, as good engineers, it is our duty to make them consistent by making some efforts. So today we'll be learning that there are two types of consistencies. First is called as strict consistency. Okay, this is strict consistency. And then the second one is called as eventual consistency. Okay, so let us understand what these two mean, what the difference between them is. So suppose I have a distributed system with one load balancer. I have one server, two server, server 2, 3 servers, server 3 and server 4. And say I have a few databases as well, DB1, DB2 and DB3. Okay, so I have these three databases and I have a bunch of clients as well. Say a client 1, pardon my drawing, client 2 and client 3. Okay. Suppose now these three databases are actually not different databases. They're actually all belong the same set of database. Means they store the same data. They actually store the same data, but actually this is a single big database. You can think of it as a single big database where this database has a replication factor of 3, which means that replication factor of 3. Okay. So as this is a way of horizontal scaling where we are keeping more databases so as to share some load. Okay. Now suppose this client, suppose this entire system is that of say Instagram. Okay, Instagram. Now suppose client 1 made a comment. Client 1 made a comment and that request came to this load balancer. Then the request went from load balancer to say server 2. Then that comment, suppose the client made a comment on a particular post. That comment is stored in database 1, database 2, database 3, all the three databases. Why? Because to share some load and to protect our system from fault tolerance, we have a replication factor of 3. We are maintaining 3 replicas or basically 2 replicas of our main database. So whatever change happens in any one database, the other 2 databases replicate that change among themselves. Okay. So suppose S2 right now, here also there will be some load balancer for databases. Okay. S2 send the data to say DB3. Okay. And the comment initially was made in DB3. Now, say after some time, client 1 updates that comment. Okay. And again, the same path is followed. Now suppose client 3 wants to fetch that comment. Client 3 opens up that post and client 3 wants to fetch that comment. Say the client 3's request goes to this load balancer. From here it goes to say server 4, and from server 4 it goes to this load balancer, and then it goes to DB2, database 2. So this race condition may happen. That when client 1 updated its comment, it first got updated in DB3. Then it will take some time for that updated comment to get reflected, to get updated on both DB2 and DB1. It will take some time. Now before that happens, if client 3 also tries to fetch the comment, and if client 3's request lands on DB1 or DB2, then client 3 will see the old comment. If client 3's request lands on DB3, then client 3 will see the updated comment, the latest comment. But if client 3's request lands on DB1 or DB2, then client 3 will see the old comment. But after some time, when the update in DB3 has spread and is also updated in DB1 and DB2, after that if client 3 tries to see the comment, then client 3 will see the updated comment in all the database. Okay. Now this, what I explained to you right now, this is called as eventual consistency. Okay, all the customers or all the clients eventually see or eventually get the same data. Eventually get the same data. Okay. Till the time it is not replicated everywhere, till the time it is not replicated everywhere, different clients may see different data. Got it? May see different data. Now this is called as eventual consistency, but there is one another way. Suppose client 1 makes that comment update in DB3. Now, by the time, till the time DB3 updates that comment in DB2, DB1 as well. In all the databases, the comment gets updated. By the time that happens, till the time that happens, other users are restricted from accessing that comment. If this is the system, then it is called as strict consistency. Users or customers are blocked from accessing data till it is replicated everywhere. Till it is replicated everywhere. Okay. Till it is replicated everywhere. So this is called a strict consistency. So what did we study? We learned that whenever some update happens in one particular node, then if by the time that update gets replicated and updated in all the other replica nodes, if users are allowed to view data, if users are allowed to fetch the data, then they may get different versions of that data. Until and unless the data successfully gets replicated among all the replicas, and this is known as eventual consistency. But if the users are stopped, restricted from accessing data, till the time the data gets successfully replicated across all the replicas, then that is called a strict consistency. Okay. So I hope this concept is clear to all of you, and if you want to learn these concepts and prepare for top-notch product-based companies, Mang-based companies, and if you want to prepare for those companies directly from Mang developers, then do join CodeGurdos, and I'll see you all in the next video.